Hello and welcome to the members of the Energetic Forum and YouTube. This is Brother Mikey, alright? That's my handle. I want to talk to you about an Energizer. What is an Energizer? Who coined the phrase besides Bill Clinton? Alright, that's what I want to talk to you about. We're talking about an Energizer in the form of a scooter motor today. Alright? Because the windings have been removed in the conventional sense and replaced with two north poles. And who do we remember when we talk about an Energizer? We should remember John Bedini. Now, John Bedini had an Energizer. He had a battery, a run battery that was not radiant, and he had a charge battery that received radiant energy. The Energizers that he built are sometimes as big as Ferris wheels at the fair. They were huge. And they were slow moving. Some of them just a few RPMs, or whichever direction they went. And some of them were 12 poles of coils. Many poles all the way around, but they were all north poles. The magnets were north poles and very slow moving in most cases. So what I want to talk to you about is the little motor. The little motor that was modified originally by Matt Jones and many other people is teaching us and should have taught us something, and I'm here to show you what it is. Now, we had Bedini showed us how to take some run batteries, okay, and send it to an Energizer right here, and usually in form of a fan for mechanical energy, and it would go through this motor and into that battery right there. Can we see that? Yes, we can see that. Just checking my camera. I'm not the best cameraman in the world, but so I may have to check it now and then. But in this experiment, John taught us that these batteries were not radiant, and the energy that was running through this Energizer went through there and into the charge battery, but some of the energy was returned back during the running process. The goal was to have a motor running that was more efficient, and the way to make it more efficient was to have the energy that was coming from these batteries go into the motor, and some of it was returned back. On top of the fact that the energy was going over here too. So that's the idea of an Energizer. Okay? Now today, some of us have advanced that idea by, now the RPM was generally no more than 300 RPMs, and there were large magnets involved, very large. Neo magnets were not suggested. It was just large ferrite. Okay? Ferrite magnets. Right? And those large coils. We had maybe 300 RPMs. Right? So how can we improve that? How can we get more? We need more RPM. So somebody come up with something that doesn't cost as much. And to make it more compact, like you would with three-phase, you increase the frequency and you lower the amount of amps and things like that. So instead of 300 RPMs, we want an Energizer that does 3,000 RPMs. All right, 10 times more. And that's what the scooter motor does. Now today, we still have the same run batteries over here, and it's running through a scooter motor like this, just like this, and then here's the shaft, the mechanical shaft. You can put a fan on it or whatever you want to do, but that's not what I'm here to discuss. There's a certain amount of mechanical, just like there was with any Energizer. And then the electrical part. Okay, so let's make it a block. Let's call this a motor with an X on it. And the energy comes from the run batteries. And in our case, it's two positives. Here's another battery. And this is a positive terminal right here. And this is negative, and this is negative, and this is positive here. So you run it on both positives. Now it's an Energizer, which is meant to run, and while it runs, it charges this battery on the differential. Okay, and then as it runs on each pulse, it returns some of the energy back to the run batteries, while it's feeding radiant and transient spikes into this battery right here. Now these batteries are not to be radiantly charged. Not necessarily, but who knows? Possibly they are getting some radiant. But one thing we do know is that what we learned was the cable that goes from the Energizer motor, whichever one you're choosing, needs to be thicker. You want that to be fatter, so that, because we've learned that the radiant travels on the outside of the wire, so we want that thicker. But all in all, what I come here to share today with you is my ideas that I'm finally realizing that the smaller motor, the scooter motor, is an Energizer, and it looks like that, and it works similar. This is my idea of how it works, okay? You have a rotating shaft like this. We'll just make it a pictorial. And you have a coil of wire that goes around each pole like that. So you have two coils, and you have magnets. You have a magnet here that's arc-shaped because it conforms to the body of the motor. And this is your rotor going around. Now there's 4 of them in our case. I'm not going to draw this one because it'll be in the way. So we have 4 magnets. We have a 4-pole, I guess, but it's really only a 2-pole. And it goes to a commutator here. And the way it works is that the battery feeds power to it right here. Well, let's just do it. This is not exact, but you're going to get the idea. You have a battery right here, and it has the 2 poles. And sometimes during the commutator, one side of the rotating rotor, the coils on the rotors, these are 2 north poles, is connected. All right, one side is connected. And then when it turns, the commutator switches the this off. It will turn this one off. And now this side is connected. All right? and it goes back and forth like that. It connects this side, then it disconnects that side and connects this side. Back and forth. And so what was wanted to happen with an Energizer is that you would turn on and off the coils, and as it goes around, some of the energy in the coil, when it was switched off and then come back around, would go back into the battery as it was being energized. I guess, I don't know if that's the best way to describe it or not. And then there would be the pulse, the transient spikes. But we have to remember that this magic, or if you want to call it that, cannot occur unless we have the 3 battery generating setup, which means that we have 2 plus poles here, and the negative one goes down and around to this negative. These are negatives right here, and the negatives, you end up with a differential. And that's where the switching takes place, right here. This positive and this positive, 12 here and 24 there. So we have 12 volts available, but it has to be done where this switch is on, right there, and then when the rotor turns, that unhooks, and now this one is connected between the positives. Some of the energy of the 2 north poles is returned back to the run batteries, and this battery, the radiantly charged battery, is getting transient spikes like we've heard before. Spiking the battery is good for the battery, and so on. And so that's how an Energizer works. Only in this case, we could have 5,000 RPMs. So we could have 15 or 20 times more spikes and more activity with one little tiny motor for one low cost, rather than build a great big huge Ferris wheel, okay, like John Bedini did. So that's what's on the menu with these small motors. So you can take these big batteries or little batteries, and you can, what you end up with, and I'm going to tell you, when I run my inverter with a light, I'll run my 3 batteries like so, just like I had it, with the negatives connected, and jumped over here, and I have the 2 positives again right there. Now run my inverter. Alright, INV inverter, and then I'll have a light bulb right here. Now here's my light bulb, and it's lighting, and I am using 1 amp, 1.0 amp, or 1,000 milliamps. Or let's say 1.25. That's what I'm using today. Amps. When I run this between the positives, this battery goes down and this battery goes up, just like any other split positive charging. These are 12 volt batteries, 12 volts, and the light lights. And every hour I get a drop with a 1.5 amps and 12 volt differential. I'll get an X amount of drop on my battery. Now I'm monitoring my battery. I get about a 0.05 drop. So that would be if I started at 12 volts, 12 we'll say, and 45 volts, and I got a 0.05 drop, what would I have? I would have 0.040, because I dropped 0.05, right? Right. So every hour with my inverter, drawing 1 amp, 1.25 amps is more what I'm running, and then I get a 0.05 per hour drop, okay? If I hook my motor up to my Energizer motor now, not just any motor, the brush contacts are not all what's taking place. It's not just a brush discharge that we're looking for. If I hook my motor up to 1.5 amps, I get a 0.02. This was the figure that was talked about on the 3 battery, and I thought, well, what the hell does that mean? 0.02. 0.02 of what? 0.02 of the moon and the stars? What is that? 0.02. But I began to realize that with these small motors, there was a limitation. These small motors that everybody was working with, these, these scooter motors like this, with the feet on them, your regular scooter motor, they can only handle so much power, and they start getting hot. You got to go to a bigger motor. So everybody's running them about an amp, 0.1 or 1.2 or 2 at the most, and they start to warm up. 2 amps, right? 2.0. So I'm thinking, okay, depending on the size of your battery, well, then you got to stay within the C20 rate. And I begin to realize what the 0.02 meant. 0.02 of what is the first question I had, and the answer lies in the C20 rate, and the average load that the motor will handle at the sweet spot, if you want to call it that, we'll say 1 to 2 amps, something like that. So with that, you need a certain size battery at 1 or 2 amps. And so let's just say we pick 1 amp at the C20 rate, right? So there's a certain standards that go with this if you understand that you have to be within the C20 rate. So then the 0.02 started to make more sense. That was the drop per hour. And then as before I got my motor working, and I was just using the inverter at 0.05, it really didn't come clear until I ran the motor. So when I ran the inverter, I had 0.05 drop for 1.25 amps. Am I reaching anybody here? And for the same amps, 1.25 amps, I'm only getting a 0.02 volt drop. Okay? That's been verified many times, and I just did it this week with the 3 battery. So remember, I thought, well, why can't I just use 1 battery then? But it doesn't work that way. So now today what we're doing is we're running batteries like this around in a circle, and we're using a pump or a converter to run the hot leg of the motor right here. And then when this fills up too much, we're sending another pump back to these batteries. We're pumping the energy back into these batteries, so we're losing, with our pumps, we're losing some percentages because of circuit. But this helps us to keep from swapping the batteries. We don't have to swap the batteries around physically. We don't need a great big welding switch with 50 amp capacity and clunk, clunk, clunk around and find our, get our big wires so we can swap back and forth. Besides, the batteries don't like radiant, the ones that are running. Who taught us that? At least this is my opinion. I could be wrong, but who taught us that? Who taught us that the run batteries and the charge batteries. Now after it runs a while, it will almost be zero. Okay, so now let's well, it will be zero once you stop it, but right now it's going to catch up the pack. It's just maybe 500 milliamps, and the battery voltage is stabilized here on the run. Okay, so now I'm going to hook up the Energizer is hooked up and ready to go right here, and through the booster, if I hook the red one without turning the booster on, I can hook up the red one and it'll start right up. See it there? And see the amps? They went way up. Let me show that to you again. Now watch the amps go way up. See it go way up to 10 and then back down, and then this is the input voltage right now without turning the booster on. Now I'm going to turn it on with this green wire, and this is the proper way to start the system. There it goes. Now it's on. And you got to remember, my faulty meter is a little off. I can't zero it, but that is 1.2 or 3 amps right there, right in that vicinity. And of course you can hear the motor climb up. Now let me hear it go down. Now I'm going to plug it back in. Ready? Hear it? I'll do it again. Ready? See the amp drop? Now it'll drop way down, and I'll plug it in. Hear it go up. Can you see that? I hope it's focusing. Alright, so here's the point in case. I showed you what an Energizer does. It switches on the commutator. In this case, this is an ingenious invention by a fella named Matt Jones. And he worked with this motor for 10 years. I'm just the Johnny-come-lately guy who tried it. And if you guys think it's cool, give it a shot. Okay, it's running at 3.75 amps, maybe? Yeah. It's 16.5. And this thing tends to climb up on the motor. The more it runs, the more it climbs up. And I can't even lower it at this point. If I lower it down a couple of points, I don't even need the booster to help pump it up, but there's a diode or something in there that creates an optimum speed or a resistance so that it limits the amount of power going from the battery. But either way, running like this, I measured it. It was 1 amp at 16.7 amps. I measured it with a meter, and I'll show that to you right now. Okay, you got to be quick. You got to be quick with your hand here. You see this? You see this meter right here? Now I'm going to jerk this thing off here with this, and then I'm going to run it again, but I'll have to turn it, and I run the risk of pulsing the heck out of this thing, but I'm going to show you. Now this one is running, it's running a little bit more. It's running 1.2, about 1.2 amps is what it's running. And I keep fiddling with the back plate. I'll keep adjusting it at times and trying different settings. Now there it goes back on again. And you'll see each time. And the run batteries never change. See the run batteries over here? What I like about the run batteries is that they always stay full. But they're called upon. And it's going around in a circle. Some of the power comes from here, and it goes through the motor, and then it goes through into the charge battery, but right away is swept up by the booster and sent back over as needed to run the motor. So it's creating a big path, and we don't have to swap batteries with this method. But the point in case here is that as I've been talking, and you know, turning it on and off, we're messing with the point count. But you will see eventually that this, if I just sit here and hold it, you're going to have to take my word for it. If I just sit here and hold it, you'll see that this will just sit there forever. If I were to use an inverter, the point count would drop very consistently in a few minutes. But with this system, or with this motor, I'm going to turn it off and turn it on and see if we're teetering on the edge of a computerized, this is a computerized meter. See how they bounce between the digits? If they're, it's sensing whether or not it's 1217 or 1216. And it's saying, no, I think I favor more 1217. And it will, I ain't kidding you, it will sit there forever. When you begin these experiments, you need to sit and hold your breath a little and just go at 10-minute intervals or 15-minute intervals and see how quick that motor goes, pulls down the batteries. Now look at that battery. Excuse me. That battery is being drained out at a rate, this charged battery, it's being charged, but it's being drained out at the same time at 3.7 amps. And then it's being fed some power. And this will just sit there forever, running and running and running. And what I like to do is to play with the booster. Now inside here you can get your little watch screwdriver. Listen up and I'll be quiet. Hear it go down. Now that's where I usually start, with about a 1.2 amp draw and about 13 volts on the differential. I haven't measured the differential for you. But if I go back to this meter here that I originally showed you, or a minute ago, you can see that I was right, because I was at 16 volts most of the time, and then I'll have to turn it sometimes on these motors. Okay, now watch the amps. See the amps? Now, in this case, it's still about, well, it's a little less. And I can still turn it down further. Alright? So about 16 watts. A little over 16 watts is supposedly what this motor is taking. But is it? Because if I were to draw the same 16 watts, which I have been doing with this inverter, not on right now, and I have that other blue inverter, if I drew that 16 watts on those inverters, it burns that power right up, and I get a 0.05 volt per hour point drop. Okay, see, it's still back to 12.17 because I lowered the consumption a little. This is where I normally rest. Okay, it's going down a little, and so I'm going to make sure it stays at 16. So I'll adjust it. I won't have to keep doing this, just when I first get started. Now that's it. I'm sure there are more automatic controls to be invented on this. But what we have is two boosters. The charged battery booster is hooked up, and it's charging up the run batteries. And then through this booster to power the motor at any specific voltage or RPM. Now listen to this sucker wind up when I crank it up. You ready? And I'll be quiet. I'm going to crank this up for you to about 5 grand. You ready? Here we go. That bad boy is screaming. I could crank it up a lot more if I wanted, but I'm not going to do that. I just rewound it, and I want to keep it in one piece for testing. So I run it down here for now, and I'm observing the savings that this Energizer offers. We all have heard a million times that a coil stores energy, and that the key to keep maintaining the battery with an Energizer is to return some of that energy back to the battery that's feeding it. In this case, this is a split positive system. So there I'm back to that, and my amp draw is down pretty good. It only goes up a little more when you crank it. So that's what's happening. Now what I was doing also was I was thinking, hey, I'm going to hook up some motors, and I'll be right back and show you. Okay, so I'm back, and here's what I did. I put, you see the two clamps on here? I have a motor that's saving me power, so I thought I'll put a generator on that and see what I can do with it. And so I put this big one on there, and wow, does that thing offer a tremendous amount of resistance. It's just a tiny little stepper motor, but you talk about cogging. These things will break your arm right here when you try to power anything. This thing is hard to turn right now, even like, ooh, that's really hard. And the amp draw goes right up. And then I thought, well, I'll just put a real little one on there, right? So I got this real little one here. Here's a real little one. Now I know better, because with my lens-free generator, if I don't have my coils right, any little amount of coil energizing will drag down the motor. I already did that before. But I wanted to show you what a lot of people think. They think that if you hook this up to a stepper motor, here's a real little one. See how little it is? You think, I got free energy with this motor. I got an Energizer that saves me a little power, so I'll hook me up a little generator, and I'll throw that back to the battery with a bridge rectifier, right? Here it is. Here's my rectifier, and I hooked up the cables back to the battery, and it just, I mean, this thing right here only drug the motor down a little bit, but as soon as I'm powering anything with it, this goes up an amp, and this provides me about a few milliamps. Okay, so this is a very inefficient. We need a Tesla coil lens-free generator, and that's where we're going next, guys. Okay, that's it for now.